In this example problem, what we're going to be looking at is atomic masses. When you look on a periodic table and you see the atomic mass, that atomic mass does not represent the mass of just only one isotope. That atomic mass represents the weighted average of all the isotopes that are contained within that atom, within that element. So a particular element may have several different types of isotopes. If you take a weighted average of all those isotopes of that particular element, you come up with what's on the periodic table as the atomic mass or the atomic weight. In this problem, what we're going to be looking at is we're going to be looking at magnesium. All right, magnesium is going to have three atomic masses, or three isotopes. I'm sorry, three isotopes. So you have magnesium 24. Magnesium 24 is going to have a mass of 23.9850 atomic mass units, and it's going to be an abundance of 78.99% is going to be its abundance. We can also have magnesium 25. All right, it's going to have a mass of 24.9858 AMUs, and its abundance is going to be 10%. And then the last isotope of magnesium is going to be magnesium 26. And its mass is going to be 25.9826 atomic mass units, and its abundance is going to be 11.01%. If you add up all these percentages, you will come up with 100%. Now, how do we come up with the weighted average? What we're going to do to come up with that weighted average, or to determine the atomic mass for magnesium, is we're going to take the percent, convert that into a decimal, times that by the mass, take that number, we're going to do that to all three of these isotopes, and then sum them all up. All right? So in order to do that, convert this into a decimal. So it's going to be 0.79, oops, that's an 8. 899, multiply it by the atomic, or by its mass, 23.9850 AMU. Sum now we're going to take the 10%, that becomes 0.100 times the mass, which is 24.9858 AMU. Then we do the exact same thing with 11.01%. This becomes 0.1101 times the mass, which is 25.9826 AMU. When you do this arithmetic, what you end up with is you end up with 24.306 AMU, which will match very close to what you find on a periodic table, because the periodic table's mass, atomic mass for magnesium, is going to be the weighted average of all three of these isotopes. If you have any questions on this problem or any problems similar to this, please let me know.